So welcome to the next lecture. The what we are studying the carrier modulation, digital carrier modulation. After that one we have studied until now binary amplitude shift keying and MRA amplitude shift keying. Similarly BPSK frequency model, that is frequency shift keying. So amplitude shift keying, frequency shift keying and phase shift keying. Out of phase shift keying we have studied the BPSK, that is the binary phase shift keying, and quantity phase shift keying. This is what we have studied. Now another modulation technique is the what we are calling QAM, quadrature amplitude modulation. So as already we have seen the previous case, it is the combination of the amplitude shift keying and phase shift keying. So quadrature amplitude modulation is a form of digital modulation similar to PSK, except the digital information is contained in both the amplitude and phase of the transmitted carrier. With the QAM, amplitude and phase shift keying are combined in such a way that the positions of the signal elements on the constellation diagrams are optimized. So generally we are calling it the optimized modulation technique here. Suppose it is 8 QAM, it is M array. Again if you take, so 8 QAM is the M array encoding technique where M is equal to 8. Unlike 8 PSK, the output of the signal from the 8 QAM is modulated is not constant amplitude signal. So this is a briefly outline the QAM transmitter and the receiver. It is a more or less looks like a PSK. So channel 1 input and a channel 2 input. Again is the multiplying with the oscillator here and a 90 degrees phase shift here is a sine here. So the in phase and quadrature component, it is a cos signal and it is the sine signal. So multiplied and added here. Similarly the receiver side is just opposite to this one. Again the signal is transmitted here, after this one is receiving here. So again we are generating a carrier signal here. Okay, with again the 90 degrees phase shift we are going to get here the in quadrature phase component. So in phase and quadrature component again we are multiplying with these are the two we are calling as the low pass filters, and again converting to the analog to digital conversion and parallel to serial converter. So this is the another way of the representation. Again a quiz test on the QAM. So QAM is formed by combining either ASK and PSK or FSK and PSK or ASK and FSK or none of the above. So the answer is ASK and PSK, combination of the ASK and PSK.